I'm going to go over all the odd solutions here, and it'll be your job to finish this up. But check to see that you got these odds correct, or make the corrections that you need to on them. In the directions, it says your answer should only contain positive exponents. And the big key to remember here is the negative exponent does not mean that you have a negative number. It just means that something wants to switch positions, as we talked about last week. And one of the first things that we talked about is anything to the 0 power is actually 1. So your first answer, 2 to the 0 power, is 1. I will be proving this fact tomorrow with a couple of exponent laws that we'll learn about, and you'll get to see why everything to the first power actually, or to the 0 power, is actually 1. All right, moving on to number 3. We have a negative number to a negative exponent, and the one thing to keep in mind here is that the negative number is included in the parentheses. That means it's going to be included with the exponent as well. Now remember, everything is always over 1, unless it's already in the denominator, but this is just on its own. But this negative 3 tells me that this is not happy where it's at, meaning it wants to move position. So it's not happy upstairs, it wants to move downstairs. And we are left with 1 on top, and now this becomes negative 4 to the positive 3rd power. And then it's just our job to figure out, well, what is negative 4 to the 3rd power? Well, that's negative 4 times negative 4 times negative 4. An odd exponent with a negative means I am going to get a negative. And 4 times 4 is 16, times another 4 is 64. So 1 over negative 64, or negative 1/64, however you want to write this, would be the answer to that one. Okay. So that one did happen to come out negative, but not because of the negative exponent. Remember, negative exponents mean we're just switching positions. So for number 5, one common mistake here is, remember that numbers have their own exponents. So 3 is not to the negative 1 power, it is to the 1st power. And anything to the 1st power is just itself, but it's the positive 1st power, so 3 is fine with where it's at. The only thing that's not happy is this k. It's to the negative 1st power, so that wants to move. But the 3 is okay, it wants to stay there. So this equals 3 over k, so now the positive 1st power, or just 3 over k. And that is my answer to number 5. Alright. Moving on, number 7, actually very similar to number 5. Y is to the 1st power, x is to the negative 2nd power. So this is the only thing that's unhappy and it wants to move. So y over x to the 2nd. Once it moves, remember, then it turns positive. Alright, moving on to number 9. 3 different terms here. We got 4, a u, and a v. And again, remember 4 is to the 1st. The only thing that's unhappy is u. Not you, just the variable u. You know, you're all happy, I know that, so, because you're in math class, so that means you are happy. Alright, u to the negative 4th is going to want to move. So we've got 4 to the 1st, or just 4. V to the 3rd stayed, and now u is to the positive 4th power, and it's much happier down there. So yes, now u is happy, just like all of you are. Yes. Okay, moving on to number 11. This one's a little bit interesting. We've got a fraction. One thing is happy where it's at, y is happy, x is not happy. So y is going to stay. X wants to go chill with y in the basement. So we've got x to the 2nd. I'm going to put that out front, y to the 3rd, and 1 on top. So those two things are now being multiplied on the bottom. You could rearrange it, so it's 1 over y to the 3rd times x to the 2nd. Doesn't really matter. Either of these would be okay. But remember, when one thing is happy, it's going to stay, and the other one you have two things that are unhappy where they're at. So remember, 3 is to its own power, it's to the first. X wants to move, and Y wants to move. So on top, we will have 3 times now Y to the positive fourth, and then on the bottom, X to the now positive third. So just our variables swap places so that they would be happier. All right, so those are our negative exponent examples. And remember, when you have powers of 10, or when you've got 10 involved with exponents, that is something we can treat a little bit differently because it means our decimal is just going to move when you multiply or divide by tens. So we talked about scientific notation, which is what these numbers are in, and the directions ask us to write the number in standard notation, which means we're just going to turn it into its decimal number or whole number, whatever it comes out to be. Remember that something to the negative power actually means that this equals 1 over 10 to the third, or 1 over 10 times 10 times 10. So really, you're dividing by 1,000. This is 1 over 1,000. Or multiplying by 1/1,000. So that means our decimal actually moves to the left. So on the most basic level, you don't have to know that or remember that. But for scientific notation, this is just going to indicate that it's going to move our decimal to the left. So 1, 4, we're going to move it to the left 3 spots. So 1, 2, 3. My decimal is now here, and then these get filled with zeros. So my answer is 0.0014, or you can put a 0 up front there too if you want to. Okay. Alright, 5.9 times 10 to the 5th, positive exponent, which means I'm just going to move my decimal spot to the right, or that I'm multiplying by 5 tenths, so 10 times 10 times 10, 5 times. So we're going to go to the right this time, so 1, 2, 3, 4, 5. Place zeros in here, and our final answer is 590,000. Alright. Number 19, 3.4 times 10 to the third. Positive power, so we're going to move our decimal to the right 3 spots. So 1, 2, 3. Placeholders for 0. Our final answer is 3,400. Alright, so that's just applying a power of 10. Going from scientific notation to standard notation. And then the last few here just want us to write the number in scientific notation. So we need to figure out where to move that decimal place to, and then which power of 10 we can multiply it by. So for number 21, we have 0.004, and we want to turn that into scientific notation. Remember that your first number in scientific notation has to be greater than or equal to 1, and less than 10. So I'm going to want to move my decimal right there. So that is going to give me 4 times 10 to the something. Now, to get from the place where I want my decimal back to its original position, I have to go back 1, 2, 3 spots. So this is going to have to be to the negative third. So 4 times 10 to the negative third power is the same as 0.004. Alright. 23 and 25 are pretty similar. We need our decimal to be between 4 and 4, so we get 4.4. Currently, the decimal is hanging out right here. So in order for me to get from the place I want my decimal to where it is, I go 1, 2, 3. So we need that decimal to move 3 spots to the right. So there's our scientific notation. 4.4 times 10 to the third power. And lastly, very similar to 23, decimal, we want it in between 5 and 3. It's currently it to get it back to its spot. 1, 2, 3, 4. So this will be 10 to 10 to the fourth, and there we go. All right, so like I said, tomorrow we'll talk a little bit more about some exponent laws and go a little further with some of this stuff. But finish up this sheet, and I can take questions tomorrow.